Hello everyone. So today's question is on basic networks. So you are given a square waveform of +4 to -4 amplitude, and the frequency is 1 hertz, and inductor has an initial current of 1 ampere. You have to find the value of I load, the average value of I load. So what is I load here? I load is IL, I inductor, plus, let us assume this is ID, I diode. So I diode. So for taking average, we can write I load average, that would be equals to I inductor average plus I diode average. So we can separately find the average value of inductor and diode, and then simply add them. Okay. So I have explained this concept many times. Like whenever the inductor is connected across a constant voltage, the current in that inductor will be linearly rising. That I have told. Like what is the value of VL? VL is I L d IL by dt. So what would be IL? IL would be 1 by L integration VL into dt from minus infinity to t. Okay. So if VL is constant, it would be VL into t by L. So it would increase linearly. So in this case as well, the input is -4 to +4 amplitude, so the current would increase linearly. So in this case, like this is our input waveform, so what would be the current? So the current would be like this. First it would increase, then integration in negative direction, then decrease. So basically we are integrating it. Okay. So what would be the current? Current is Vt by L. So V is over, let us assume 4, and we are okay, let us write T, and L is 1. So our IL is 40. So 40 it would increase linearly. So what would be the value here? 4 into 0.5, that would be 2 ampere. So from 0 to 2 it is increasing. So what is this? This is IL. But load I not IL dash we should see we should say. Okay, but the inductor is already having 1 ampere current. So the inductor current would be so the IL dash we should say. So IL would be 1 ampere plus IL dash. Okay, 1 ampere shifted upwards. So this graph will shift upwards by 1 ampere. So this is how the graph would look like. So this is IL, 1 ampere, 3 ampere. That's how. So now we need to calculate the average value. So that's where everyone would go wrong. So what would be the average value? Average value. So what would be IL average? IL average will be this area divided by 1 second. So that's how we calculate the average value. So it would be 1 by 2 into 1 height 2 plus, like first we calculated the area of this triangle, then you should add this as well. Okay, plus 1. So it would be 2 ampere. So that's the average value of inductor current. Okay, now we have to calculate the average value of diode current. Now as per the input waveform, whenever there is +4, the diode would be off and there would be no current flowing through it, and whenever there is -4, the diode would get on. And what would be the voltage here? -4 plus 0.7, it would be 3.3, -3.3. So the current flowing through it would be -3.3 ampere. Okay, +4 diode off, -4 diode on, and -4 plus 0.7 -3.3. So current would be -3.3 ampere. Okay, so that's how the waveform would look like. Now what will be the average value? The ID average would be -3.3 into 1 by 2 upon 1 then time period. Okay, so it would be -1.65 ampere. So what would be the I load average? It would be 2 minus 1.65, it would be 0.35 ampere. Okay, so that's the final answer. So it's a very simple problem. What we did, first we find the value of inductor current, then we took the average. While taking the average, we need to see that we have to calculate this area. Okay, and then simply divide it with 1 second, and then we calculated diode current average. Okay, so then we added both, so we get 0.35 ampere. So that's the final answer. Okay, thank you.